The main idea for this session is to walk through the main components and the main aspects of IEC 62443 and also share a bit of knowledge about what to expect during the certification process. So we do intend to stay at a pretty high level and not dive too much into the details. So if these details are what you're after, we can make use of the Q&A time at the end of the presentation, or you can also reach out to us and we'll be happy to find some additional time to get as nerdy as you want about 62443. So getting started with a sort of a refresher on what is IEC 62443 and what it covers. During this presentation, there is one term that will keep coming back and back again, which is Industrial Automation Control System, or IACS. This is something that you may have heard it referred to as cyber physical system. And so the initially IEC 62443 was developed to secure this industrial automation control system in the industrial, let's say, process sector, mostly because that's where these IACs were generally found, in industrial processing sectors such as manufacturing, for example. And then that quickly expanded, let's say, to other critical areas such as transportation, power generation, and also a lot of other critical infrastructure. And then this standard gained more and more traction, mostly because, let's be honest, IT standards usually don't work that well with the operational technology world. They usually focus on direct or indirect economic consequences, whereas the OT part would have very different performance or safety or availability focus. Life cycle is also a major difference between these worlds because we often see IACs which are expected to operate for years or dozens of years. And during this long life cycle, the focus is much less on the direct economic consequences of a breach or a failure, and more on the, let's say, public health, potential lives, or even societal impact that the cyber attack could yield. And that's the reason why IEC 62443 addresses the technology aspect of a control system, but also the work processes, also the countermeasures, or even the employees operating it. Because in a context where a failure or breach could have catastrophic consequences, the training, knowledge, and skills to ensure security are critical security measures and potential countermeasure. Finally, it really operates under the principle that if the OEM and operators identify what's most valuable, what requires the greatest level of security, they will be able to focus their effort on securing these crown jewels, focusing on the core objective, whether it's protecting against external attacks, for example, but also ensuring continuity of operation or fail-safe mechanisms, or what have you. So based on these principles, and since the OT world expects or requires a high level of confidence in the implemented security measures, it gave birth to a certification scheme that covers different areas of operation technology. So this IEC 62443 is sort of an overarching reference of standards, technical reports, technical specifications, which cover a wide array of content. It starts with generic consideration to make sure that we're defining the assumption and hypothesis that we're going to operate under. This is what you can see on the general part at the top of the slide. Then it defines the policies and the procedures that should be implemented around the operation of industrial automation control system, the policies and procedures part. Then it does dive deeper into the technical consideration of how components will interact with each other. So that's the system part. And finally, it defines the requirements that apply to specific components and also how they are going to be developed. So in this case, these components are sort of the basic blocks of a system. So the focus for today will be on the standards that are marked with a stamp in this slide, corresponding to the standards for which certification can be pursued. So in term 2-4 about security requirements for IACS service providers, 3-3 about system security requirements and security levels, 4-1 about the product development requirements, and finally 4-2 about the technical security requirements for the IACS components. So we will discuss in more details about each of these, but first let's see who can pursue these the certification according to these standards. So as you can see here, the spread of responsibility between the original equipment manufacturers and the system integrators, well, there's a good amount of common sense in there. Because, for example, only OEMs can implement proper software development lifecycle to rule how components will be developed. Only the OEMs can define how these components will actually interact with one another to form a complete IACS. And then the responsibility of system integrators is especially important when it comes to defining the proper set of rules, the proper set of policies according to which they will be deployed, as well as conducting the proper testing of the security requirements. So now if we try to dive deeper into each of these areas and standards that can fall under the scope of certification, starting with 4-1, secure products development lifecycle requirements. This one is heavily process oriented. It aims at ensuring that there is a software development lifecycle in place to conduct component development, but also that this SDL is able to support all the activities. So it goes much further than just defining a set of processes. The certification will also try to make sure that the accredited test lab and the certification bodies have a reasonable level of assurance that said software development lifecycle is in place, is operating properly, is operating with the right amount of evidence, with the right tools, with the right template for the team to operate, and things like that. So this covers a very vast array of practices in order to go from the very beginning of the design phase all the way to the end of life, with activities such as threat modeling, for example, in the early phases, and how to deliver product documentation in case of security update, how to ensure proper testing of said updates, etc. So for some of you who may be developing rolling release of your product, or who may want to apply for a certification for a product that is already under development, this poses a challenge about when to start and how to make the most of the running start that you've already had. And we'll discuss that briefly in the challenges part of this presentation. So moving on to 4-2, the technical security requirements for IACS component. So in this place, you already have your SDL in place. It's already been 4-1 certified, and the development team is ready to apply the defined processes and to develop a product accordingly. So products that can be developed under 4-2 certification must fit at least one of the definitions provided by the standard. And so let's get a bit verbose on that part. These can be either a software application, so a software program and dependency that are used to interface with the process of the control system. So that could be, for example, a configuration software or the historian of your control systems. It can also be an embedded device, so a special purpose device running embedded software designed to directly monitor, control, or actuate an industrial process. It can be a host device, so a let's say a generic purpose device running an operating system who's capable of hosting one or more software applications, data stores, functions from one or more suppliers. So, for example, if you intend to rely on a commercial operating system to host your software application, this implies that you need to make sure that this operating system implements the proper security mechanisms to help you secure the complete deployment. The final type of component that can fall under this type of certification is a network device, which is defined as a device that facilitates data flow between devices or restrict the flow of data, but may not directly interact with a control process. So your standard OT-oriented firewall, for example, would fall under this definition. The 4-2 standard also mandates a lot of testing to ensure that the advertised security mechanisms work as expected, and that the technical requirements were properly implemented during the development lifecycle. So that covers, for example, the user authentication part, but also the robustness and the load and other aspects that you can see listed on this slide. Finally, something that's also important, the scheme provides 4 certification levels for a component, which offer, say, increasing levels of security assurance, numbered from 1 to 4. And this targeted security capability level will be part of the certification that is issued for 4-2. Now, your SDL is in place, your components are developed, are available, and we can start talking about system security assurance with 3-3, system security requirements, and security levels. So this is once more a set of criteria to fulfill when you pursue 3-3 certification. First of all, the control system must consist of an integrated set of components. What this means is that if you only have one single component in your deployment, for example, then that's just a component, that's not a system. Then the second criteria is that the control system may include hardware or software from multiple manufacturers, but it needs to be available as a single offering from a single supplier and supported by a single supplier. On top of that, it requires that the control system is under configuration control and under version management. And this is sort of a disclaimer by IEC to say that if your system is not using configuration control and version management, you won't be able to achieve certification anyway, so don't spend energy on pursuing it at the moment. Something interesting is also that there is no requirements about sizing or scalability. So both fixed size and scalable deployments can be certified under a 3-3 scope. So 3-3 certification also relies on 3 main categories of requirements with regards to software development lifecycle assessment, which would be kind of similar to 4-1 that we discussed earlier, functional security assessment, and finally the vulnerability identification testing, which is the more hands-on part of certification. So these testing elements cover items such as the user authentication, authorization, the interfaces protection, and so on. Finally, what I think really showcases the risk-based approach that we briefly mentioned in the introduction is the fact that a system can actually consist of a mix of various zones of different security levels, because basically the scheme expects that in complex deployment, external communication may play much less of a role in ensuring the functional safety of the system than, for example, monitoring or actuation. Fourth part and last one for today, the Secure Service Provider Process Certification, which corresponds to the 2-4 standard security program requirements for IACS service provider. This part provides a set of requirements and about security capabilities for the IACS service provider that they can offer to the asset owner during both the integration and the maintenance activities. So these requirements are really focusing on processes, but these standards has a very nice side that is really straight to the point with somewhere like 15 pages of context and introduction and straight on to 50 pages of appendices with the actual requirements, starting with ensuring that you've got the right human resources put in front of the right roles, that they've been properly trained, but also covers subjects such as assurance, such as architecture aspects, and incident response, and so on. So, as with every certification, it's important to sort of weigh the benefits and the extra work that this will imply on the development teams to decide whether pursuing the certification is let's say aligned with the strategy. And what we've seen that basically every company, whether an original equipment manufacturer or a system operator has different ways to look at the value of certification with a very different set of criteria. Though we do see some of them come back more often than not. And these have to do with, for example, the zone of influence. So this certification that we're pursuing, will it be recognized in the main country, in our main country of operation, but also will it be recognized in other countries we operate in, and will it be recognized in countries where we may want to operate in the future? The type of coverage is also very important, because that's basically what dictates the level of assurance that you give about cybersecurity as a whole for the industrial automation control system. So this is where it shows whether the information is mature enough to have an actual value for the client you're addressing. The scope is especially important because it defines what part of your operation the certification will cover, ranging from lifecycle issues to supply chain management and a lot more, like testing during the development. And yeah, the final, let's say, question that we want to see addressed is what will complying to the standard actually bring you? So this can help show a higher level of cybersecurity maturity, for example, which can in turn open new market. It can also sometimes mean something much more pragmatic and down to earth, such as complying with local regulations, for example. So about these positive sides and aspects of getting certified, these can really be seen as showcasing the security of product to the customers. Especially in that context, IEC really pushes into dashboard standards for OEMs and system integrators and asset owners to use these 2-4 compliance to negotiate contracts between all these parties. This also shows that you've been paying proper consideration for the whole life cycle of an IACS, from the very beginning of the design phase until the end of life. This can also be used to answer requirements by government institutions. So we've seen a growing number of OT-related cybersecurity incidents, and yeah, let's say in a tense geopolitical context, it can be especially important to showcase that you've paid proper due diligence with regards to cybersecurity of your operational technology, especially in critical areas such as power transportation. Finally, there is also one very nice thing about it, is that it really helps linking the maturity of the OT side with the IT side, mostly because the maturity level of IEC 62443 are in line with CMMI model. So this means that you can sort of bridge the gap for with regards to maturity between one side of your infrastructure and the other. Now, if we focus a bit more on the specifics of the certification, the certification scheme is operated by IEC, and our objective as a Bureau Veritas company is to provide a consolidated engagement team in approaching that, and as much as possible, a single point of contact for both the licensed test lab and the certification body to, let's say, make the communication that much more efficient. So in this situation, that means that two main companies play a role in that. The first one being LCIE, also part of Bureau Veritas, which plays the role of certification body. So they are the one allowed to actually issue the certification. And in order to decide whether this certification can apply, they rely on reports from a licensed test laboratory, which is the role Secura plays within the Bureau Veritas company. So yeah, one other thing that is worth mentioning, if that was not made clear from the previous part, if you want to pursue a 4-2 certification for a product, it needs to be developed in accordance with a 4-1 certified software development lifecycle, which may pose a few challenges that we'll discuss a bit later on. Now, with regards to the international recognition of this certification, you can see here a list of countries who are a member of IEC. So this gives you a very good insight on which countries will this certification be recognized with. But the nice thing is that the corollary is not necessarily true, because IEC 62443 is also recognized by countries that are not member of IEC. And this clearly shows when you go through, for example, US-centric or European-wide frameworks that refer back to IEC 62443 as an efficient way to address the cybersecurity of the OT environment. Now, we thought it might also be interesting to have a look at what the actual certification project may look like from a communication and workload perspective. So everything starts with the agreement between a customer and a testing lab. So testing labs such as Secura in this situation. The idea is that this initial synchronization, this initial agreement will dictate how we interact during the whole of the compliance and certification roadmap. We can also link this initial agreement with a, let's say, an initial gap assessment in order to provide insight on the level of compliance of your actual existing processes and products with the requirements. Then, since the certification body will be the company in charge of issuing the certificate, their input on the mode of operation and the scope is obviously extremely important. We can really see these two initial steps as an opportunity to synchronize and to make sure that we all agree on the, let's say, on the fact that the approach makes sense and that we'll be able to deliver the most value in the end. And then we move on to the actual evaluation activities with first the intake of documentation and evidence, because as we mentioned earlier, this is a heavily process-oriented certification. So we expect to receive a lot of information, a lot of documentation, a lot of guidance on how you're actually going to implement all that, and also testing evidences and evidences that things were properly implemented, for example. So once we've got that documentation ready, then comes the time for the assessment, where the licensed test lab are performing the actual technical assessment on the product or reviewing the documentation that was provided early on. Then comes the audit and reporting, because these certification process also include a formal, let's say, interview step to make sure that the teams that will operate under the scope of certification are actually knowledgeable and ready to apply all these sets of processes. And then finally, the certification body decides whether a certificate of compliance can be issued. So this is really fine on paper, but in reality, we do often encounter some challenges when going through this process. And that's why we think it's important to share a bit of feedback about these. So for most of you, if not everyone, software development life cycles are already in place. They're already in use. So it's important to get a clear idea of how compliant they are to the IEC 62443-4-1, for example. So independence requirements will forbid both the licensed test lab and the certification body to provide some sort of advice or recommendation during the certification process. So it's very important to get this initial overview of what needs to be adjusted in the current software development lifecycle. Though one thing that we would like to highlight is that assuming you have the proper internal audit skills and capacity, this activity can actually be conducted internally. The main challenge that we see with that will be then to make sure that the people in charge of this internal audit have the proper level of trust and independence from the development teams to provide some unaltered vision of the situation and proper advice. For the second point, I try to make a parallel with the IT side of things. not all companies who rely on ISO 27K, for example, will pursue certification. So this can imply that IEC 62443 can also be used as an inspiration and a source for cybersecurity best practices, for example, even if you don't go all the way through certification, or even if this certification step is pushed a bit further in time. Finally, the scope of certification is extremely broad and ranges from very process-oriented to very technical requirements. And I do think that IEC made very good work of making a lot of sense in IEC 62443, which really shows when you skim through it, though there is still a high amount of complexity within it, and driving compliance will likely require an internal IEC 62443 champion, someone who's able to adjust your processes and your tools to specific requirements, or also to sort of bridge the gap between the two, or even translate them from one side to the other. So we briefly mentioned maturity levels earlier. They're closely linked to CMMI, and they provide a good bridge towards the IT-centric frameworks. And yeah, to elaborate a bit on that, for example, a maturity level 3 implies that you've already applied your processes. So in the case of a 4-1 certification on your software development lifecycle, for example, ML3 would imply that you already developed a component in accordance to your SDL, and you have the proper evidence to support it. Though, if you apply these processes before being 4-1 certified, your component can't be 4-2 certified, since it's not been developed following a certified software development lifecycle. So it's really important to address this matter early on in the compliance project, mostly so you avoid running into a chicken and egg problem. So one way into this situation could be that ML2 certification is achievable even without having actually applied the processes. So it could be a nice way in, and getting your SDL certified according to 4-1 ML2, and then using your product development of a 4-2 certified component to gather the right evidence to pursue a higher level of maturity for certification. On the other hand, we really want to stress that maturity level 2 is not a low-hanging fruit. There is, let's say, it goes much further than just defining a bunch of security requirements for your software development lifecycle. It also means making the right tools available to people who will be in charge of actually implementing this process, making sure that the right people are actually knowledgeable of what processes they will have to implement in the future. So there is still a decent amount of complexity into achieving maturity level 2 certification. Regarding the testing part, especially for 3-3 and 4-2, so systems and components, the testing can be carried out by the licensed test lab. So in that case, we really like to highlight the fact that providing at least 2 devices under test will allow for much more efficient testing, mostly because it allows 2 sets of tests to run in parallel, or it allows us to keep a control sample to compare behaviors, for example. On the other hand, testing can also be done by the customer himself with the licensed test lab only reviewing the evidences. So these will only rely on the ability of the, let's say, of the customer and of the licensed test lab to come to a reasonable level of assurance in the efficiency of the testing process. Finally, we discussed earlier that lifecycle for OT products is really different from the IT world, with product being maintained for very, very long periods of time. This does not mean that this product cannot be certified under IEC 62443. But that does bring on some challenges on deciding how to approach it. For example, synchronizing certification effort with the release of major milestone or major version. The same sort of issues may come with development processes, where a new version of a component are released very often, such as rolling releases, for example. So once again, that does not mean that certification cannot be achieved. It just implies that some extra discussion with the licensed test lab and with the certification body will be required just to agree on how to align the certification effort with the specificities of your development lifecycle. So, in conclusion, we really do consider that IEC 62443 provides a comprehensive set of standards that allow to show cybersecurity maturity in the cyber-physical domain from the very beginning of the development phase all the way through the operation. So a very nice way to, let's say, tie everything together. And this is would like to work with people.